Well, hello everyone, and welcome to today's education session, Code Hot Topics, presented by Tom Zuzik, Project Consultant and Code Compliance Services, and NOMMA's Code Advocacy Consultant. And a big thank you to our sponsor, Besden. Here are a few housekeeping items to review before we get started. We are recording this session, so you'll be on mute throughout the presentation. If you would like to ask a question, please raise your hand. And now let me introduce today's sponsor, Besden.
Besdan is a second-generation family business founded by George Besdan. His daughter Margaret, alongside Carolyn, continue to lead Besdan with dedication and vision. We design and develop high-quality stainless steel components for glass and cable railing and feature products in black stainless steel. We know railings, but it's our people and the trust we built with our customers that truly set us apart.
Hi, my name is Darwin Ortis. I'm the National Sales Manager for Besdan Railing Solutions. As you saw in the video, Besdan has been providing railing systems across North America for over 65 years. We specialize in glass, cable rail components, including complete post systems that can help customers reduce shop time and help installers achieve great results. We are well known for our high quality products and our in-depth sales support, ensuring our customers' expectations are exceeded. Our black stainless options in both glass and cable rail is something we're really excited about. Customers tell us that the factory applied coating using the PVD process eliminates some of the challenges you may have with local powder coaters, as well as exposing the high-end look of the stainless steel grain. We invite you to jump on our website, have a look at what we offer, and request a login. We value our industry partners, and once your login is set up, you'll have access to trade pricing, some volume incentives, and free ground shipping. Thanks very much for listening today, and I hope you enjoy the rest of the webinar.
And now let me introduce today's presenter, Tom Zuzik Jr. Tom has been active in the railing industry for over 25 years. He has been active in the building code and standards arena since the mid-90s. Tom is a past recipient of NOMMA's Frank Kozik Award, the Julius Blum Award, and the Cliff Brown Award. He presently is president of railingcodes.com, which provides project review, code consulting, and detailing services. Concurrently, he represents NOMMA at code hearings and fields code questions for NOMMA members. Thank you so much, Tom, for being here today, and I'll turn the webinar over to you.
Good afternoon, everybody. I hope you can see me in this little screen. We're going to go over many little things, but 3 or 4 of you had emailed me about specific topics before this webinar. And if you have a question about something, please add it to the chat. Betsy will see it in the chat. And if you have a question that you want to verbally ask about what we're looking at, just raise your hand and then we'll let you in. It's a little hard if everybody just starts talking or somebody forgets to turn their microphone off to hear everything. So with that, one of the areas that I'm going to start with that is a huge hot topic is handrail terminations. Now, what you're looking at here is what I try to explain to clients, which are NOMMA members, mainly, what you need to do to be able to present multiple different aspects of terminations to your clients, whether it's Commercial or residential, your terminations are going to be very similar other than where they terminate. So this page that you're looking at here is a breakout page of a stair flight with mitered returns and radius returns, and it is a breakout of all similar type terminations. Like if you have a radius bend commercially, per the ADA and pretty much most building codes today, and NFPA 101, you need to go your 12 inches at the top of the stairs before your inside of your radius starts to bend for your change of direction. Same thing goes when you return it to a wall. At the bottom, here's a radius bend to the floor, radius bend to a post back. And what this is that I've produced here for a client is a standardized page that goes in with all their submittals so that when they're being reviewed and the architect or the designer or anybody on the site, the contractor, looks at it, they know that you have taken the time to review and laid out your handrail terminations so that they comply to code. For this client, we have the code adoption section plus the ADA plus, I'm not sure how many of you are familiar with handrail bracket sizing and the clearances, but the ability to list out this information. Now, why is this important? Areas of the country like Maryland, Georgia, Florida, I'm not sure how many of you on here deal with NFPA 101, which has got a 2¼ inch clearance between the wall or your obstruction and the inside of the handrail bracket. One of the biggest problems that I run into when trying to help out fabricators is understanding that when an architect draws these details, you need to communicate that you're working off a center line, because your bracket standards, unless you're custom making them for the architect, pretty much most of you will probably see a dimension here from the side of the handrail to the wall or the guard or whatever it is that says 1.5 inches. And that's an incorrect way to designate the way that the handrail clearance is being reviewed. And why do I say that? Because it's a minimum of 1.5 inches clearance. And most off the rack brackets that you all are working with start at 2.5 inches, go to 3, go to 3¼ Your larger 3 and 3¼ are going to be for when you run into NFPA 101 and you need a 2¼ inch clearance. Because if you're using a standard 1.25 inch Schedule 40 pipe for your handrail with a 166, which is what this is based on, okay, and you have a 2.5 inch bracket, you can see here that you have the clearance of 1.5 inches plus. And we'll get into this little radius portion down here in a little bit, but one of the other parts of the code and ADA and ANCA 117 and in NFPA 101 is, that's my reminder, I'm late, is that as your perimeter grows, every 1/2 inch over 4 inches, this height here at this measuring point for the clearance reduces underneath from 1.5 inches minimum to 1 inch and 3/8 to 1.25 inches to 1 1/8 to 1 inch, depending on the dimensions. And we can go over that if you have some more questions on that. But this type of page in your submittals, when you're looking at your handrail terminations, will drastically reduce giving your client and the reviewer at the architect of record, whoever's reviewing it, or the engineer, the building official, whoever's reviewing your documents, the knowledge that you have listed out and reference back for your pieces. Now, it's important to understand all these different terminations and how they affect, because some of you may have a mandrel bender, some of you may have a manual bender or a Hausfeld, and your radiuses are going to be different. But the key is to remember that your clearances, which are your minimum extensions, have to be met before you do those changes in direction. Now, I'm going to give you a little bit of what I call an overload. This is the 2010 ADA, the 2017 A117, and pretty much anything that you're dealing with newer IBCs past 2018. But this is showing a stair flight that's got an open tread on the side and showing that these darkened areas here are on the landing. This is on the landing, this is on the landing. This line here is your brake. This line here is your brake. This is your landing. And this is showing all the pieces that you can go together. One of the biggest issues that we find in reviewing that a lot of you run into is when you're at the top of a ramp, they don't give you this landing zone to clear with your handrail to the inside. And they normally will give you 12 inches from the brake line to the end of the wall. Well, your handrail has to project past that because you have to get the clear of the handrail past that zone. Another important piece to understand is if you're dealing with a stair flight and a ramp that intersect, okay, this is another one that a lot of people miss and get into trouble with. How many of you actually know that you cannot connect the handrail of a stair flight to the handrail of a ramp that is in the means of egress for the ADA compliance and A117? It is against the federal code and in the law, and it is against A117. These brakes are required so that the blind or the visually impaired know that they're done at the top of a ramp. They can be continuous from ramp to ramp to ramp like you're seeing here, but they cannot be continuous to a handrail. You can't connect a handrail to an actual handrail of a ramp to a handrail of a stair. And I'm sure a lot of you work in areas where you have ramps that run around like this and tie into stairs, and they want you to connect. That is a compliance issue and one that is very largely missed out there. Another one is where the bottom stair riser, your nosing point, is right at the point of a stair here, and then the return of a wall, and the architects will turn it and then run it 12 inches, or it is not compliant. It needs to go out. Now, why is this important? Well, if the firm you're dealing with has a non-compliant design and you bid it and put it in, you own it. And as a fabricator, you need to understand that very strongly, that you're the professional. You need to know the difference between doing it right and doing it wrong. Doesn't matter if the architect drew it wrong. Doesn't matter if the building department didn't pick it up upon review. It matters how it's built and how it's installed. So it's important that you understand these termination points. Okay. So where is that? Well, here's one on a ramp that you'll see a lot of times. Come down, point. Here is your compliant handrail extension. Here is your non-compliant handrail extension. This is no good. Somebody chime in there? I don't see any hands. Okay. Here's another one. This is an important one that a lot of people miss on. If you look here real tight, you'll see that this radius is turning into the wall before you've reached a minimum 12 inches. This is not, hello. Okay. So it's important that you understand that this is a huge factor that will come. You may get past the architect, you may get past the builder, you might even get past the building department. If somebody falls, you're going to be on the hook for the non-compliance as you go down the road. Okay, so it's very important. I get calls on these or emails on these at least twice a month for how do I talk to them to explain it. So mitered handrails will get you a closer reduction because you don't have the radius, but they also give you this point, which is not good also. It's a trade-off. I always suggest if you have the ability to radius bend. If you don't, you need the room, you can tie it in and miter it. It's not wrong, it's just play on the safe side. And here's an example of two compliant. Here's a mitered bend right to the wall, and then here's one that doesn't even go. There's ways to play with the different type of handrails, extensions, and radiuses, but for the most part, they're all the same. This is our handrail clearance, and these are the stair flights. Before I move on to the next topic, which has to do with handrails on, I think Greg Terrell emailed me the question on the next topic I'm going to cover, which is stair width and stair flight width and handrails and clearances. But does anybody have any questions, or am I boring you because I've given this to you 18 million times?
Can you hear me?
Yes, go right ahead.
All right. Can you go over the specific verbiage in the code? Because this comes up a lot in our industry where they don't give us enough room for that 12 inches. And if we have enough room, we try to go the 12 inches before our return to the wall. But I've had architects argue with me and GCs argue with me about the IBC code not explicitly saying, or the ADA code not explicitly saying that, you know, it's a turn in direction in the handrail. Technically, they argue that the handrail is still extending forward in the direction of the ramp because the verbiage in the IBC code says that the extensions of the handrails shall be in the same direction of the flights and stairs at the stairway and ramp runs at the ramps. They argue that technically that bend is still going in the same direction as the stairway, and as long as the bent area is still above 34, it's still within that 34 to 38 handrail height, even if it's within the bend downwards or the bend towards the wall, that is still code compliant.
This again might take a little bit of time for me to bring up only because we're in the middle of a Zoom meeting. And I'm bringing up the 2024 code because, and you can get a hold of me afterwards. So this has been a topic for a long time. And ADA, if you go to the Access Board's website or go to ADA's, get a interpretation done by them, okay? It's explicit. So if we go back to 2015 and the verbiage tells you before any change in direction, the code changes that changed the language to make it more identifiable were all done based on the terminology for the reason statement being that it's editorial. Editorial means that they're just clarifying something that is misconceived out there by the architects. So when we look at this, this is the 1014.7 handrail extensions in the IBC. The extensions of handrails shall be in the same direction of flights. This is important. They must be in the same direction. So the extension and the handrail have to be in the same direction of flights of stairs at stairways and ramp runs at ramps. That language has not changed. And shall extend the required minimum length before any change in direction or decrease in clearance required by section 1014.5 or 1014.8. This was put in there as a clarification for this because it's a misinterpretation, and it's one that you're specific about. Because if we go to, and I hope this comes up. So if you go to the ADA website and we go to guidance and resource materials, no, law and regulations, and we go to chapter. Yeah. It changed the website on me. I apologize, everybody. Let's see. Okay. We go down here to chapter 5. Handrails. Handrail extensions. Handrail gripping surfaces shall extend beyond and in the same direction of stair flights and ramp runs in accordance with 50510. Extensions shall not be required for continuous handrails at the inside turn of switchback or dogleg stairs and ramps. I'll go into this a little further when we get down. In assembly areas, we're not looking at that. In alterations, full extensions of handrails shall not be required. This is an exception only when there's an alteration. If you have a complete rebuild on a building that goes into a level 3 alteration based on the IBC's existing building code, this gets kicked. Where I was talking about here, extensions shall return to a wall guard or landing surface or shall be continuous to the handrail of an adjacent ramp run. Remember I was telling you stairs and ramps can't connect? This is where it's delineated. Now, if we now take this information that we just spoke about, that you're talking about, and we interpret the change in direction, and then we go to the access board, chapter 5. Stairways. They move. If you email me, I will get you the correct link. I don't want to take up a lot of time right now to find that specific wording.
Sounds Sounds good, because we have it, they push back a lot on this, and I've actually had people make pretty good cases that the handrail return to the wall, technically the railing is still continuing in the direction of the ramp or the stair, and that graspability, the IBC 2024 code that you brought up before, does attempt to clarify that.
Just
I
so you
just had it
know,
up, but it does actually have a, it has, if you jump back to that IBC code you had up. So it says, shall extend the required minimum length before any change in direction or decrease in clearance required by those sections. If you go to section 1014.8, it actually, if you just scroll down a little bit, has an exception for the decrease in the clearance due to the curvature or angle of the handrail returns shall be allowed.
yeah, that
So,
was clarified in the last code cycle and
yep,
removed. That it was not. Just so you know, everybody understands, I'm working with the editorial committee for ANSI A117, and the figures that you're seeing here will be in the next publication of the A117, showing that you have to make these before you hit these clearances. So this is not new, it's editorial, and what that means is, so that you all understand a little better, the doesn't have to go through the code review process because it's editorial to be closer to the text. Okay, and figures are non-enforceable. Does everybody this is an important part for everybody to understand. Figures, which these are not enforceable for the ADA or A117 or the IBC or any of that. It's the text. And that's what the architects don't seem, they try to poke holes in the text versus understanding what the actual text says. And they can say, okay, well, this is the way we interpret it. And when you say to them, okay, that's an incorrect interpretation that we know through talking through the code consultant, are you willing to go out on a line and bet your reputation on it? Because the lawsuit's coming to you. Okay. And 9 times out of 10, which is why I go back to, if you give them if I can find it. Oh, here it is. I'm sorry. If you give them a sheet like this, which has the text, this is the 2018 IBC for PA, with the information, and you list it all out along with the ADA and the compliance issues, if you put this in your drawings and list it in that manner and add references to the interpretations that I will suggest you get from the access board, and you won't really get one from ADA because it's a federal, you're dealing with a lawyer and they're not too helpful. But you can go to the access board to get an interpretation. And if everybody doesn't know, that's the US Access Board. And they published a guide to the 80-day accessibility standards. And you can always go to this technical assistance. Okay. And I know a couple of the people there. They will get back to you. You can email them or you can call them. I suggest you email them with your information and what you're calling on. And 9 times out of 10, when you're dealing with an architect, when you get a interpretation back from the access board that says they're wrong, they cave. And that's the easiest way I can tell you to start fighting handrail extension issues. I don't know if the guys from think it's Schickel. One of them, they ran into this a lot, and once they got their interpretations down, it started going away. But a quick call works, but an email, they get back to you normally within 24 to 48 hours. Okay. Any other questions before I move on? Okay. So one of the issues that a lot of people have a hard time understanding is, where do you measure handrail or stair width? How does the handrail fall into? And stairs are different than ramps. But this was a interpretation I did up a while back for another NOMMA member. And they had built a guard and they were getting hit because where do you measure the width of the stairs from? So when you're measuring a stair flight, you're measuring above the handrails between the guard and the wall. So if you have 46 inches between your guard and your wall above the handrails, and your minimum height requirement is 44 inches, you still have to maintain that 46 inches on the guard between the wall and the guard. However, what a lot of people don't realize is, if you don't have a wrappier handrail and you have your stringer above the floor level at the landing, you're actually measuring to that point under to the guard above the handrail at your wrap. So how does that look? So we do a cut view here. And I'm just going to take this portion out for a second. So here's your stringer at the inside. Here's your stringer around the outside. The stair width has to be maintained between the guard and the wall above the handrail coming down the flight. At the mid landing, you have to keep that same 48. So if you don't have the handrail here, you don't get to use the wall. You have to use the stringer, because this is where the wall starts. It has a setback because there's no handrail here. Now, I'm not going to read this fully out for you, but the highlighted portion here shows projections into the required width of stairways and ramps at each side shall not exceed 4.5 inches at or below the handrail height. So the handrail's allowed to come in to 4.5, 4, whatever it is, and you're allowed to then put a level on the inside of that handrail, and everything below it, even though it's in the landing, is no longer required not to be there. So now, in this case, I forget who I did this for at the current moment. Their problem was they had the guard here in line and came up, and their handrail wrapped around the inside. So they were measuring 4.5 inches closer. So they were 43.5 inches to the wall, to the guard, not 48. So they actually had to modify their guard up underneath and come back and come up and add this little knockout at the return, which was this small piece in the guard right here, so that they could keep and use this measurement above the handrail here and above the handrail here to get their 48-inch clearance. Greg, did I cover that pretty good for you on this? This is an important piece to understand. And this all falls back to the required stair widths. And I'm not sure how many of you have actually seen this section, but when the architects calculate it, they have different areas within the building. They'll build out a table and it gives them allowances per person, how many square feet they need for each type of location. So like an educational classroom area, you need 20 square feet per person in that room. Business area gross is 150 feet gross, okay, per person. Assembly without fixed seating, 15, unconcentrated. Assembly without fixed seating concentrated is 7 square feet. Kitchen, for every 200 square feet you have in a kitchen, you're going to have, it's a gross calculation. Library, stack area, 100 square feet per person is based. So what you're dealing with here, when it's then overlaid into the building plan, you'll see here that they have 80 seats, 87, 82, 80 seat, 81, 82. The 80 seat is what they're designating they're going to put in there. The 81 and 82 are the calculation that they did for the room square footage. And then you'll see they have these dots in the furthest part of the room, and they come this way and they go down, and they come this way and they go down, and they go into the stairwell. And they add up all this information, okay? They're splitting this room in half, okay, 120 seats. They're going to put 60 here and 60 here, or half of 126, 53, and 53. But they're going to then take that, and it's going to be counted out that they came up with, on this floor level, they have 333 people times 0.15 equals 50 inches for the minimum width. So the minimum width is 50 inches. The minimum width, clear width of the stair flight is going to be 50 inches. It's going to be based on the largest amount that's hitting this stairwell, and floors don't stack. So if you have 50 inches, if you have 333 people on this floor and the one above has 400 and some, it's going to take the largest number in the stair tower that's connected, and it's going to use that for the minimum width. They're provided 68 inches. So the minimum width is 50. They've provided 68, and the stair flight is based on the 68 to come down. Now, what's important to understand is you'll see that there's a stair flight here right in the middle of this open area. But there's no dotted line going down those stairs because that is not a fire egress stair. That is not your exit access. This stairwell is the designated exit area, not this. And when we go to the other end of the building, you'll see that this one goes this way, okay? And then they don't have them for here, but they know that these have to be calculated in. And when we look at them over here, we got 315 people. So if we start adding all this up, we'll see we get to the 315 people, okay? And then it comes down this stairwell. Then when you go down to the first floor, you'll see, again, we have these breakouts, and they calculate the number of people with the required and provided widths, okay? And if the stairs entering into here and the stair is wider, then this width is going to be wider here, but this could be narrow here. Here's your stair. Here's your exit out. Here are your exits out for here, going out to here, the equipment rooms. This is where all that stair width that you deal with is calculated, and how you have to understand that sometimes architects will make the width bigger just to plan for the future. Now here is an elevational view of that same plan. And you can see stair tower on this end, stair tower on this end, and here's that convenience stair that is not allowed to be used for your designated means of egress. Okay? Everybody get that? Follow where I'm going with that? So when we go back to this information, knowing what your minimum width is calculated as is important, because these stairs here, okay, could be 50 inches. Let's say it's calculated and you've got 44 here, but you come over here and you got 48, that's fine, because the mid landing can't be smaller than the stair flight. Okay. Okay. And these are all the code sections for that. All right. So let's move on to some new stuff coming down the pike. Interpretations that are out there. Handrail profiles are a big issue. What's compliant? What's not compliant? How does it work? What can you use? How many of you run into issues with using a traditional Dixie cap for like a ramp? They say you can't use it. It's not a round or an oval or a rectangle in those manners. The type 1, type 2 classification, when you're figuring out a handrail profile and its handrail bracket, this is one of the biggest misconceived information for your vertical clearance under your handrail profile. We were talking about the calculation for the handrail, and this is not the one I want. I apologize. I apologize, everybody. It closed out on me. So one of the biggest misconceptions is the calculating handrail clearances that we were talking about before with the profile and the reduction of this area underneath, which is the vertical clearance. And see if I can find it in here. Nope. So the section in the code that we want to look at is in ADA, it's in 505.6 gripping surfaces. This is where the designated gripping surface horizontal projections shall occur 1.5 inches minimum below the bottom of the handrail gripping surface. Exception 2, the distance between the horizontal projections and the bottom of the gripping surfaces shall be permitted to be reduced by 1/8 of an inch for each 1/2 inch of additional handrail perimeter dimension that exceeds 4 inches. So that 1.5 inch minimum till this projection comes out can be reduced by 1/8 of an inch for each 1/2 inch of perimeter. When we go back to our profiles, and here are some different profiles giving you the 15, you'll see that the Julius Blum 4534, this is the perimeter, all those dotted lines. It's not a direct line across here. So you count all that distance. Now, if I take that and I put it on top of a flat bar or something else in that manner, we'll see here with that added, the perimeter is 5.333. It didn't change much. Well, why is that? Well, instead of going in, it went out. But the 533 helps us. Why does it help us? Well, we know that 533 that we have here for this handrail profile, okay, is going to get us in the neighborhood, well, 1/2 inch. It's going to get us a 1/4 inch reduction because it's 1/8 for 4 to 4.5, 1/8 from 4.5 to 5, and we're not at 5.5 here, so we're not getting our extra, but we're getting a 1/4 inch reduction on this height. Okay. And when you're using a handrail profile, typical Dixie cap, with a flat bar underneath, you can get a reduced reduction and get into those other handrail brackets that don't have the true 1.5 inch like you'll see in some of the off-the-shelf catalog pieces. And depending on what their projection is in those bends, you have to do your clearance from the 1/2 inch, 1.5 inch from the actual side that's inward. So if you have a wider piece here, like a traditional cap, that's going to go into the wall with a 2.5. Whereas if you have a 1.25 inch, which is a 166, you're going to be able to use a 2.5 instead of a 3-inch bracket. And these are common mistakes that are very prevalent where a lot of your fellow fabricators get hit. Everybody has, I know this is like watching paint dry, but these are important factors that you need to understand with handrails. Okay, so I'm going to open it up to see if anybody has any specific questions at this point. So I can cover everybody's, and you can always email me questions directly at coderep@railingcodes.com, and I'll be more than happy. I will not, so that everybody understands, I will not answer a code question on listserv unless it's generic and not for a project. Please understand that I do that for your safety and your liability reasons. You don't want to be publicly posting something you did wrong on listserv. So if you have a question about something, you can always ask a question, and I normally reach out to you directly. If it's something very generic, like the testing procedures that I did for, I forget the gentleman's name down in Louisiana, it's important to understand that you don't want to be airing your dirty laundry on listserv in that manner, but you can contact me directly. So if you have a question, please speak up.
Just a quick one on your stair clearance. If you can jump back to your tread width and landing clearance. Did you say that if there's a handrail that wraps around the landing, you can measure all the way to the wall, but if there is not a handrail wrapping the landing, you have to measure to the back stringer projection? Did I hear
Correct.
that right?
That's correct. If this handrail is not wrapping around the entire landing, so if your handrail is coming out and terminating here and coming out and terminating here, you have to use this inside stringer edge. However, if your handrail goes continuous around the whole entire piece, then you can use the wall above and gain the extra 2 inches or inch and a half, whatever your stringer thickness is at the wall.
And which specific code verbiage refers to that?
If we
Like where
go
you can use the
to,
handrail, but not the,
well, where it is, okay, is stair width. So it's a multi-part reading, okay? And the stair width is measured let's see here, handrails height required. Lateral location. It's a new one, came out in the latest. One time continuity, fitting hammer extensions, clearance. I'll have to, whoever that is, email me and your location. I'll get you the exact notation. But it is, handrails are measured because, you know what, it's probably up here. So protruding objects shall not reduce the minimum clear width of accessible routes. If it's not an accessible route, okay, and the basic language, if you'll follow me for a second, an accessible route is a ramp or walkways. A means of egress for emergencies is not really an accessible route, because an accessible route means you need to be able to get in and out with a wheelchair. So that's why protruding objects shall not reduce the width, and you would measure between the handrails. And that's why handrails are measured, ramps are measured between the handrails, and stairs are measured between the walls. Okay. So I got to pull that out. It's a three-part piece where you have horizontal projections, post-mounted objects, and the stair width. But I can get that for you.
We have a question in the chat.
Go ahead.
Is there any text in the IBC or ADA guidelines that requires a continuous handrail on both sides of the stair at the landing beyond the required extensions we discussed?
There is not, with including handrails are only required on, well, let me put this in another manner. Handrails on stair flights are required to have handrail extensions. So the handrails are only required over the stair flight, and they must have their extensions at the top and bottom landings. If you do not have enough room at an inside turn to terminate with a full compliant handrail extension, and you have another stair flight that's at an inside turn that wraps, you can go to continuous to that handrail on those stair flights. Ramps, and I'd have to find the exact text, are a little different. Ramps require handrail extensions. However, let me draw this and just make it a little easier. If you have a ramp, you have a landing, and then you have a ramp, and you have a mid landing, and then you have a ramp, and then you have a landing. Okay? There is a distance, and I don't remember the exact distance. This has got to be a minimum of 60 inches to begin with. But I believe if this is under 7 or 8 feet across a mid landing that is continuous and straight, that the handrail has to be continuous. But I'd have to find that text for you on that. I don't know who asked that. But as long as you're able to have a mid landing that you can terminate handrails on, then you're technically, you don't have to be continuous, but there is an obscure one for small mid landings that they require. An example, and it's only in straight runs, because one of the big things that they're looking at right now, that we're looking at editorial wise, is how many of you run into a ramp that you've got a 90-degree turn at a mid landing like this. So you come into the ramp and you're coming down, and then you're coming into the mid landing and turn, and then you're coming down. This is an accessible route, which means that if this is 60 by 60, and this is the break on the ramp right here where you level off onto the landing, this is going to be non-compliant. This is going to need to be pulled back a minimum of 16 inches. And this is going to need to be pulled away a minimum of 16 inches. And the reason this is the handrails, if they enter into here, reduce the minimum 60 by 60 width. So you need to have your ramp come down and your handrails terminate into the walls or floor or whatever it is before they enter into this area. So that means 12 plus the width of your handrail material, which we're going to say 2 inches. So you want a little bit of playroom, which is why I said 16. So this is level. This is level. Now, if you bring the handrail and run it continuous through here, you have violated the 60 by 60 square inch area. This is something I could spend a whole lot of time on when you're looking at ramps, things that you need to look for to see if there's even enough room for you to put on your handrails for compliance. And this specific diagram that you're looking at, figure, is being changed in the upcoming 2027 ACA 117 publication. It will be changed. You'll see it corrected there in the figures.
Unfortunately, I think we've run out of time. I think we have 1 minute.
So I know this is a little tough, but you're more than welcome to reach out to me for more explanation. Greg, if you want to do a short Zoom meeting, I'll do Zoom meetings with NOMMA members. That's what I'm here for. for you all to call me about specific pieces. It only gets a little tricky when it gets into asking me to provide a formal, if I have to put something on paper that you're giving to somebody, that's not covered by your free service with NOMMA, because that goes on me. But for general questions, I'll normally be able to walk you through, show you where the information is, and then you can use it with the clients to get yourself out of hot water. Okay?
All right. Well, thank you so much, Tom, and thank you to all the attendees for your participation. This webinar is part of NOMMA's new webinar series, so please check out the events calendar on the website under Events Calendar, and that'll give you a list of upcoming webinars and other events. Your feedback is very important to us, so please complete the brief survey that I am about to put in the chat right now. And I will also email you this link to the email that you used to register for the webinar. And this concludes our session. Thank you and have a great rest of your day.